Okay, since there were a lot of people asking about how to operate this monstrosity, I've decided to record this video explanation so you will understand how everything is supposed to be set up. First, there is a blast furnace. It will convert your iron into molten iron. Then there is a copper stove, or rather there are two of them. You need two of them because they work in pair. One heats up, the other discharges, and they switch sides from time to time. You need to switch them manually. I will talk about that later. Then the smokestack. Smokestack is this multi-block structure that is used to consume all of the excess gases from the network pipeline and to vent them out into the atmosphere so nothing clogs up. Then there are molten canals, as you can see. Using this tap, you can pour molten metal from the blast furnace into the canals, and canals carry this molten metal into molds, barrels, or Bessemer converter. Molds are used to form your final materials or items. The mod adds molds for plates and for ingots, as you can see, double ingot mold. You can pick up any mold. Now you hold it with your both hands, as you can see, and you can place it down into mold pedestal. When there is molten iron or molten steel in the canal, it will fill up this mold automatically. Then you can pick it up. Here we have these molds here. Probably back that out or not. That will, you can pick them up, then place them down. I don't know why they don't render right now, probably some issues from previous versions. By the way, this is a change from the vanilla. In vanilla, you cannot pick up molds with iron inside them or molten metal inside them. Now you can. So, how all of this is supposed to operate? First of all, a blast furnace. It is a massive structure, as you can see. Why is this so loud? It consists mostly of refractory bricks and some functional structures, such as this molten tap and this molten tap. First one is used to drain molten iron. This one is used to drain molten slag. Slag is a byproduct that you can use later, and it is stored into barrels, as you can see. Barrels are simply buffers for your molten metals. You can pick the barrels up, sorry, like this. The barrel goes into your backpack slot. You can place it down here, and when the slag or metal will solidify, you can just chisel out with chisel. It doesn't cool down now because I have stopped the time. Right now time is posted, so nothing is solidifying, so I have all the time in the world to explain you everything. On the top we have gas outlets that allow the heated exhaust from the furnace to go out and into the smokestack or into the copper stoves. The blast furnace door is the main block that allows you to build the furnace in the first place. If you place it like this and you control right click, you can see in the projection of the structure right here, and in the chat there are information about what blocks are left to be placed, so you won't get lost when building this. And there are tiers, these blocks in the bottom that are used to transfer the hot blast from the copper stoves into the furnace. By the way, this is why blast furnaces are called blast furnaces. If you didn't know, they used preheated pressurized air, that is called blast, to heat the internal chamber to the point that the iron can melt. So it is not simply building a big furnace. And the trick is with these pipes. And the pipes are new blocks, as you can see, that can form networks. Networks need to be sealed and can be separated or toggled. You can separate the network using pressure valves. They work basically as a separator. You can see the input side by this copper textured trim, and this means that gas can flow only from right to left. And not only this, this pressure valve checks the amount of gas or pressure inside the network on the right side. If it goes over 80%, so if network overflows, then it will allow the gas to go to the left and be vented out into the atmosphere. This way you can always be certain that the heated exhaust goes directly to your copper stoves and heats them up, and not simply gets vented out into the atmosphere and the heat is lost that way. Then you can see this pipe network. It is connected to these gas outlets, and they are used to expel the usable blast, in this case, for the blast furnace itself. The used exhaust, so exhaust comes down this pipe and goes out using this outlet. It comes down this pipe and goes into the atmosphere, as you can see. To pipe the blast into your copper stoves, you need to use this access port. This is a gas pass-through block. And to produce blast, you need your gas intake and gas blower. Gas blower is, as you can see, basically a blower. There are fins that spin, and it uses mechanical power to convert simple air into blast. It pressurizes the air. What you need to know is that there is a certain limit you need to reach in terms of rotational speed. Since this is a blower, it needs to spin fast for the pressurization effect to occur. So beware. This is why I connected mines with two gear shifts, as you can see. One large gear, second large gear. So the last part, the Bessemer converter. As you can see, the molten iron can travel down to it, and using this tab, you can pour this molten iron into Bessemer converter. You can operate it using this block. For example, switch to filling. It tilts down so the molten iron can slip down its mouth. Then you set it to normal. So the iron inside can start converting. When it will convert, you need to set it to pouring like this, and it will go down this canal network to your molds. So there are two ways you can use blast furnace: to produce iron and to produce steel. I recommend going this route only after you are completed the iron route, because it is a very as you can see, expensive structure. It is big, it is made of iron and refractory bricks, and just look at this. I am in creative, so I can place it right away, but there is the cost. For rusty gears, 12 iron rods. Now here is the cost. Now the cost. Be sure that when you are ready to become a steel maker, you have first become an iron maker. Also, the Bessemer converter requires two things to operate, except for the molten iron. One is mechanical power, because as you can see, this block is big and totally probably heavy, so you cannot operate it by hand. That would be unrealistic, let's just say. So you use this mechanism that uses power from this shaft to operate the converter. The trick is that this uses some torque. It requires some power to operate. So don't connect your converters to the mm, axle line that has a lot of speed. Remember, the more speed you have, the less torque you have, and vice versa. So there are two lines to use here. Also, converters need blast as well. Not only Kovper use blast, converters use it as well, because as the chemical process that occurs inside the converter, it simply blows you the blast, so air through the molten iron to cook it basically, and fire all excess carbon from it. And this is basically the way you make steel in real life, and this is why all of this exists. So you need blowers again, and you need mechanical power, and you need molten iron. So you can just attach this to your already existing iron supply. Now let's try to operate all of this. Heads up, I've changed in the config the values, so the process will go fast. In default configs are a lot slower, so take all of this with the grain of salt, as they say. First, you need to load your blast furnace. To do this, you need to operate the hopper block and above. This is the inventory. You need to load your iron crushed iron, crushed coke, and flux, which is lime in this case. I can simply take this out of the inventory and place it down. When you have your materials loaded in, you need to start dropping down the blast mix. To do this, you use Control right click. After that, you can hear that the blast mix started dropping. This is how it looks like. You can see the hopper automatically drops it down. My time is still stopped. Let me resume for a second. You can see that there is a particle effect that occurs to simulate it's actually dropping. So yeah, if you stand in the way, the hopper cannot drop the blast mix. By the way, this is a good time to demonstrate. If you somehow end up with a blast mix, if you take out it by hand, or the pile breaks or some other stuff happens, you can simply drop it down like this, and it will automatically consume it. It goes directly into Hopper magazine, and everything will work fine. Oh, there is blast mix as well. Here it goes. So the blast furnace fills up. It fills up rather fast, by the way, much faster than it actually consumes the blast mix, so you can leave all the work for the hoppers. Simply be sure that you supply it with enough materials here. By the way, I need to add some more. Now, when the furnace is full, you can determine that by looking at the door, and as you can see, there is the count of blast mix loaded. You need 320 blast mix at minimum to start the furnace. When you have the enough amount, there is enough blast mix in the furnace, and the hopper will automatically stop when the furnace is full. You can light it up with a torch, like this. I recommend lighting up both of the blocks, because you need to wait before fire spreads across all of the blast mix piles for it to start burning. So this way it will go faster. While furnace still lights up, I remind you that you need to have some molten barrels, as you can see, that will allow you to store excess slag, because if slag accumulates too much, the furnace will extinguish. And you need to prepare your molds, because this is where you will actually receive your materials, and you need to place them. So let me do just that. I will place this here and this here. Will produce one iron plate and one iron pickaxe, as you can see. These barrels are used to store excess materials. Right now the top is blocks, so it won't go that way. Okay, now, as you can see by the sound, the blast furnace is ready. It started firing and the internal temperature climbs slowly. To help it go up and to help it reach the required temperature, I remind you that the temperature required for iron smelting is for 1482 degrees Celsius. Blast furnace will not be able to reach that temperature by itself, so we need to use this to boost it. First, we have this pipe going down from the blast furnace. It carries exhaust. As you can see, this exhaust is very hot, 900 temperatures, 900 degrees Celsius right now and rising. Uh, all of this exhaust should be routed to your stoves. To do this, I need to open both of this, yeah. And this pile makes that the stoves heat up faster, which is wanted, because we need to. This is the issue, yeah. Because we want it to go up faster and have more leeway in terms of time between the switching of the copper stoves. Also, you can see by the smokestack, it consumes gas and makes sure that your blast furnace isn't backed up by exhaust. So internal temperature is rising. This one is very hot, as you can see. This one is heating up. So we can use already heated up stove to boost the furnace. For this, we cut off the supply of exhaust. Now it goes straight into the atmosphere, and we enable the supply of blast. The blower started blowing, and now you can see there is a blast and 1200 temperature going down this pipe. The blast furnace started receiving it, and now the temperature rises up. It rises, and now it should hit the temperature of melting. Again, I boosted the stats for the melting process, so it will melt really quick. With default values, it will take around 5 minutes for the furnace to start melting. And the trick is to keep an eye on the stoves, where, as you can see, the temperature is dropping, and it will drop below 800, which is required temperature for the furnace to burn the iron. So you need to check on it and switch the stoves between each other, so they will operate continuously. The iron started melting, and if I open this, you can see that slag started pouring. I can open this tab, and it will drain into the barrel safely. Now, to drain your molten iron, you need to open this tab. It will go like this and start filling up these molds. It, for some reason, started filling up this one first. Now, both molds are full. You can remove them and place on the ground. Now you can see they will cool down eventually, and you will be able to pick out your ready material or ready item when it cools down like this. I've picked up iron plate. Now, to make steel, you need to use converter. First, put it into the filling configuration, like this. As you can see, converter drains the iron from this network. It will start filling. Also, we need to keep an eye. Yeah, we should probably switch up the stoves now. Let's do this, this, and this. Now the temperature is 1000 again. The stove is somewhat filled. You are not actually required to fill it up completely. Now, if you place it in normal configuration and it has iron and it receives both mechanical power and blast, it will start converting. Again, my timings are boosted. It will take around 5 minutes in default configuration to convert iron into steel. Now, the steel is ready. You can put it into pouring configuration. And here we go. The molds are filling. That one is filled. Let me put another one. Now, and this one is filled as well. This was filled with previous testing. I can put it out, and there is our steel ingot. So this is a full chain. Again, remember to keep an eye on your copper stoves. Remember to feed your furnace. If this runs out and the blast mix count drops below a certain point, it will extinguish. Also, if slug backs up, it will extinguish. And if this temperature goes down to a certain point, all of this will solidify, and you will need to rebuild it. So be careful and be aware of what you are doing. But if you are careful and you know what you are doing, this is a very fast way to smelt a lot of iron or steel. But if something goes wrong, for example, I open the door, you can see the furnace extinguishes. When this happens, all of the material inside will turn to slag. And let me go in survival. And you can remove all of this. When you remove these blocks, you get some slag and some other stuff back that was in the inventory of the blast furnace. Also, at the bottom, you can see solidified iron blocks. These are the iron that was in the furnace in its internal storage, but when it extinguishes, it solidifies into these blocks. You can recover some of the iron by breaking these blocks, like this. Here we have some iron bits. You can crush them in the pulverizer and load them back into the furnace. Let me go back into creative. So basically, this is the way you operate all of this. I hope it helps, and good luck.